Hey, it's Todd, and in this video, I'd like to talk to you about Oracle REST data services. In this video, I'm going to introduce you to something called Oracle REST data services, which is also known as ORDS. Now, there are other intro videos for ORDS out there, but I'm going to be talking about ORDS a lot in my next few videos to show you how I use it with IoT devices to persist and retrieve data from my Autonomous DB instance. So I wanted to get my own introductory video online so that I have something to refer you back to in my future videos. Let's dig in. So what exactly is ORDS? It's simply a way to get data in and out of Oracle DB using REST instead of SQL. With a few simple queries up front, you can expose a full set of HTTP endpoints to perform CRUD operations for a given table in your database. You can also customize your endpoints to perform more precise operations and send and retrieve only the data that you need for a given endpoint. Let's take a look at how to auto-REST enable a table for simple CRUD operations in Autonomous Database. All of the code shown in this video will be available via a link in the description below. The first thing we need to take care of for this demo is to create a user. If you'd like to try it out yourself, run the statements here to get that done, making sure to choose a strong password for your user. Next, we'll create a simple users table with a few typical columns. There's really nothing special going on here at all, which is a good way to show you that you can REST enable just about any existing table in your database. Now, enable ORDS on both the schema and the users table with the queries shown here. Our schema's URL mapping pattern in the first call to enable schema and the object alias in the second call will both be used to construct our service URL later on. Now create a REST client that could be used with ORDS. In this case, we're creating a REST client for all URLs that match the path for our entire schema. Your REST client can be as granular as you need it to be. Next, we'll create an OAuth client. You can create as many clients as you need, but make sure the grant type is set to client credentials, and grant the SQL developer role to the newly created REST client. Finally, grab the client ID and client secret for the REST client that we just created. We'll use these credentials in an initial HTTP call to generate an OAuth token and use that token for calls to the ORDS endpoint going forward. Before we can test our endpoints, we'll need to grab the ORDS base URL for our call. So head to the details page for your Autonomous instance and click on Service Console. In the Service Console, click on Development and copy your ORDS base URL. To make calls to the user service, we'll use this base URL combined with the mapping pattern and object alias from earlier to construct our service URL. Now let's see it in action. The first call to ORDS is a post to the /OAuth/token endpoint. This call uses basic auth with the client ID as the username and client secret as the password, and contains a body of grant type equals client credentials. This call returns an access token, and subsequent calls to our service will use this token as a bearer token. To create a user, we make a post request to the /users endpoint, passing a JSON representation of the user in the body of the request. This call will return a JSON representation of the newly created user. Note the ID and created dates are populated in the returned user. To update a user, we make a put request to the /users/user_ID endpoint, passing a JSON representation of the user to update in the body of the request. This call will also return a JSON representation, but this time it's of the updated user. To list all users, we make a GET request to the /users endpoint. This call returns an object with an array of the returned users and additional properties relating to pagination such as has more, limit, offset, and count. By default, 25 records are returned with each list call. This is customizable. Pass offset and limit parameters in the query string to retrieve additional pages of users. To get a user, we make a GET request to the /users/user_ID endpoint. This call returns a JSON representation of the user. And finally, to delete a user, we make a delete request to the /user/user-ID endpoint. This call returns a JSON object with the count of rows deleted. In addition to the basic CRUD operations that are enabled out of the box when you auto-rest enable a table with ORDS, you can create custom endpoints by defining a new service. In this example, we're creating an endpoint to retrieve users by username and telling ORDS the proper query to run for this endpoint. I hope this video has taught you the basics of Oracle REST data services. Creating REST endpoints is a convenient and easy way to persist and retrieve your data, especially when it comes to working with devices and IoT sensors that may have limited support for data persistence operations. If you have any questions, please leave them in the comments below, and don't forget to subscribe to my channel for more content like this. Thanks a lot.